I'm here to help you out with this second part of our Week 13 Carbohydrates and Lipids set of videos. This one is all about lipids. So I'm going to go down to item 3 here, which has to do with glycerol. And as before, what you'll want to do is bring up Spartan and carry out some of these manipulations as you go along. So for this one, I just went to the Cactus database as before and typed in glycerol. You can do that, and I'm looking at it in the regular regular ball and spoke model. The thing I want you to just take note of here is that glycerol is just, it looks like an alcohol in that it's got a carbon and then an OH, an sp3 carbon with an OH, and then it has 3 of those, and they're all kind of pointing in different directions, and so that's what makes this kind of a tri-alcohol. One thing to notice is that the orientation of these carbon-oxygen bonds has an impact on ultimately on the structure of the resulting triglycerides. Let's see. The next one that I have you looking at is dodecanoic acid. Now the numbering on here is that dodecane means 12, so this is a fatty acid with 12 carbons. And after you've brought that up in Spartan, which it'll hopefully look at something like this. The main things to notice are that it's a simple fatty acid. There are no carbon-carbon double bonds anywhere. Now there is a double bond here, but this one makes it part of the that's part of the carboxylic acid end. So there are no carbon-carbon double bonds. That's what makes it a saturated fatty acid. Let's see, it's more or less straight. And it has 12 carbons, and if you brought up the second one in this list, tetradecanoic acid, you would notice that there was 14. I'm going to go on to this cis-9 octadecanoic acid. Now the decene, the ENE part here, is a little clue that there's going to be a carbon-carbon double bond, but so does this notation here, cis. That means there is a carbon double bond. The 9 is going to mean that in the carbon-carbon double bond starts off at the 9th carbon, counting away from the carboxylic acid end of things. So let's see if that works out here. And here we have, there's the carboxylic acid end of this fatty acid, and if we count up here, there's the 9th carbon, and there's the 10th carbon, and hopefully you can see that this double bond has the rest of the fatty acid, the carbons, arranged in a cis orientation. Had that been in the other direction, had this carbon here been oriented here, then it would have been a trans fatty acid. And let's see, sometimes when the nomenclature gets a little bit more complicated, it means that there's more than one carbon-carbon double bond, and that's the case with this cis-912 fatty acid, and you can see there's a carbon here starting at the 9th position, 10, 11, 12. There's another one at that 12th position. They are both cis, and you can see that as you go along and introduce more of these carbon-carbon double bonds, especially the cis ones, it starts to sort of bunch up. It's not at all linear. Now the final item on this list is the pair of triglycerides, oleic triglyceride and palmitic triglyceride. And so the idea here is, let's see if you can distinguish various kinds of triglycerides. So here I'm going to go to oleic triglyceride, and you'll notice that this is, well, for one thing, I did want you to notice that you can see at the heart of it is this glycerin, these 3 carbons, each with an O on each of the carbons. Now, each one of those alcohol types has now joined up with the acid, carboxylic acid end of a fatty acid, and that is in fact what makes this a triglyceride, because it's happening 3 times in these what we're calling the ester bond linkages. You can also tell that this must be an unsaturated fatty acid. How do you know that? Well, you can see that it's bent, for one thing, and I'm looking at, now that I've blown it up there, here we go. there's a carbon-carbon double bond. If you looked at this carefully, you'd be able to figure out the numbering on it. Well, let's see if I can do it. Numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is once again one that has a double bond between the 9 and the 10th positions on the fatty acid.